Hola, buenos días. Bueno, tras el parón de Pascua, continuamos con el programa de charlas técnicas ligadas a la Escuela Técnica Superior de Ingeniería Informática. Y hoy tenemos el placer de repetir, porque en este caso ya dieron una charla muy interesante en noviembre, a la empresa alemana Maibornwolff. Esta empresa ha abierto una oficina en Valencia recientemente, con lo cual están bastante interesados en trabajar con la universidad y concretamente en la Escuela de Informática. En esta ocasión nos van a contar temas de tecnología cloud, que como sabéis desde hace unos años se está implantando de manera intensa en nuestras vidas y especialmente en las empresas. Primero vamos a contar con Steve, que es un ingeniero de software, que nos va a comentar un poco cosas de la empresa y temas de cómo colaborar con ellos aquí en Valencia. Y a continuación tendremos a Chamsedin y a Jochen, que son ingenieros de software de la empresa, que nos van a dar la parte más técnica. También quisiera recordar que la semana que viene tenemos otra charla, en este caso más orientada a ingeniería de software, a arquitecturas microservice. De esta charla de la semana que viene está dentro del seminario de los seminarios que está impartiendo la empresa Explora. Y nada, agradecer de nuevo a la empresa Maibornwolff que que es una empresa que, como os he comentado, ha abierto recientemente en Valencia y que está la generosidad en compartir su conocimiento y su experiencia, en este caso en una tecnología tan puntera como tecnología cloud, y en concreto a Steve, a Chanceline y a Jochen por su tiempo y por su sabiduría. Gracias.
Thank you very much. So, hi guys, my name is Steve. I'm a senior mobile developer for Maibornwolff for around 5 years now. And today we would like to do a presentation on cloud native solutions and serverless. And when I say we, I actually mean, wait, let me share the screen. I actually mean my colleagues, Jochen, Shamsuddin, and me. So Jochen and Shamsuddin, they will do the technical part of this presentation, and me, I wanted to use this opportunity to introduce you a little bit more to our company. So you might ask yourself, why is a German company now doing a talk at a university in Valencia? My colleague Paula Montesa and me, Paula was part of our last presentation here at the university. Well, we had a talk around like about 1.5 years ago about future, and she said, well, yeah, at one point I would like to go back to my hometown Valencia, but unfortunately this would mean that I had to leave the company. And when we're talking about this, we thought about, I mean, why though? Why would you have to leave? Because there's like a core principle at our company that states we don't found offices where our customers are, but we found offices where our people want to be. And this thought created the process of creating an office here in Valencia. And this also brought me personally right here now to Valencia. So we are currently 6 people here, and we love it here. I mean, I could probably say Valencia is an amazing city, amazing atmosphere, and naturally we are now looking for talents that also love working in IT, because we want to work with them and we want to give them an opportunity to do what they love and make them happy. So let's go a little bit more into the facts about who we are, because our facts actually show who we are. There's an award in Germany. It's called Great Place to Work, and it's basically awards to companies based on the happiness of their employees. And I can proudly state that now for 11 years in a row, we have been ranked the #1 company to work for. We are currently 639 employees, and we are growing. We are 31% of those are female. This would be lovely to give it higher, because we also want to support the strong women in tech. We are from around like 28 nationalities, and we have an average age of like 32.2. So we are quite a young and dynamic team. And those people that work for us, they do a lot. I mean, when you work in IT, obviously, coding is a big part of it, but it's not the only part. When it comes to successful IT projects, there's also a like phase before the coding and a phase after the coding. And we want to give customers everything. So end to end, we want to ensure the quality, like from the first stages of an idea of a project. That's why we are also love searching for the people that are more like into consulting, more into the strategy part, to work with the customers, get the idea what they actually want. And also we have a big department about like testing to ensure that the quality is also continued after the coding is done. The work with us is just different. We have a standard 40-hour work week, but most of the time when companies say we have 40 hours work week, it's sometimes not exactly this, because they're like those hidden hours that you have to give in. And so it's more like 40, 45 or something like this. But we say, no, we have a no overtime culture. So you want to make sure that you stay on this 40 hours per week. There may be times, I mean, when you have to like crank that all-nighter, for example, to make that extra effort. Of course, there may be an hour more, but this hours get tracked. So if you have 1 hour 1 week, you have 42 hours to work for, then maybe the next week you only do 38. So it has to be balanced. Everything gets tracked. We want to make sure that you also have the free time to work for projects that are not like a customer projects. So the R&D projects, the time where you try new stuff out, work something that might be interesting, and we want to give developers the time to also use this and to support them to do R&D projects. Flexible working time and home office. I mean, currently due to Corona, home office is necessary, but for us it wasn't that big of a change, because home office for us was always a natural thing, and we wanted to always support this. One extra cell leave to learn whatever you want. Continuous learning in IT is, I mean, it's very important. The digital life and time, it goes so fast, so you have to keep up. So we have to invest in them, and you need to find time for this, and that's why we give you an extra salary to take the time and to look into new technologies. And also like extra benefits, sabbaticals, health and life insurance, and people actually also use this. So we want to also state that use those extra benefits. Like I said, we are currently now in 6 people here in Valencia. We are currently working in the co-working space in Rusafa. And in the future, we are looking for our own offices, because our offices, they need something special. So something a little bit different, so people feel like they want to be there. So I want to like to show you some pictures of our offices we currently have. Right here, we are from Frankfurt, Augsburg. This is a more smaller city, like, well, 200,000 people, but not as like big, for example, as Munich. In Munich, we have actually 2 offices. This is one from the so-called Kraftwerk. Hamburg, Darmstadt, pretty young office. Got founded, I think, last year. Tunis, our other international office, have never been there yet, but I'd love to get there. And here's a picture from our other office in Berlin. Yeah, so what kind of projects do we actually work for? So we work for very big customers, obviously mostly from them in Germany, BMW, Payback, Deutsche Bahn, Miele, Mercedes, because they need good technical and digital products, and we want to make sure that they get them. To tell some a little bit about the projects I have like personally knowledge about. For example, for BMW, we work for the My BMW app. It's the mobile app that has a connection to the car, and it's one of our most successful projects, and a project I like to talk about because it gets like prized as a Google success story because it's probably the biggest app in the world that is written completely in Flutter. And we have a team, I think there are 33 teams all over the world, and one of our team works actually on very critical features for this app, like keyless access to the BMW cars. Yeah. And another project I'd like to state, this is a former R&D project. It's so-called the IoT bike. So basically, we created a software that you can attach to the bike, and it measures with sensors the quality of streets. So you see on a map actually if, like, streets need to be repaired or are not in a good of state. And this project was so useful that the city of Munich, they started to support this, and now they actually use it because they can now measure the bike paths which need to be repaired. And it's very lovely to see that it started from a like small idea from one of our employees as an R&D project because he wanted to test something out. And yeah, we supported it, and now the city of Munich is supporting it. Yeah, but I think that's enough facts about our company, because you are here to actually hear something about cloud native solutions and serverless. That's why I would now like to give the word to Jochen and Shamsuddin.
Yeah, hi. My name is Jochen. I'm situated in Hamburg. Right now, I work as a software developer for Maibornwolff for a little over half a year, almost 3/4 of a year now. Yeah, I will present today what serverless development means to a software developer, some of the real world consequences of that trend, and how it's actually being used in real world scenarios. So stay tuned for that. A little bit about myself. I studied computer science in Jena and in Hamburg, Germany. And before that, I studied kind of design focused in San Francisco for about a year. Right. Over to you, Shamsuddin. Are you there? Shamsuddin? Can we change to Shamsuddin?
Hello, yeah. Again, thank you so much, guys, for being here with us today. Thank you, Cesar, and all the folks there in Valencia for giving us the opportunity to share some of what we know today with the students of La Universidad Técnica de Valencia. My name is Shamsuddin Mansouri, a software engineer working with Maibornwolff for 1.5 years right now in the DevOps and Cloud Native department, working essentially with things with tight relation to the cloud, whether it's about managing workloads in Kubernetes cluster, enhancing the monitoring and observability of our system, or automation. It has been always for me about supporting customers in a cloud-related topic. And that's essentially why I'm gonna share in this first part of the presentation. Just let me share my screen. One moment. Yeah. I think you guys can see my screen right now, right? Test. I think that should work. Perfect. That's exactly why I'm going to share in this first part of the presentation the topic of cloud native solutions, and like you see, guys, in the agenda, what it means to adopt cloud native, the different set of patterns that forms that discipline, the solutions and some takeaways from our personal experiences, helping customers to achieve their digital, or let's call it cloud native transformation. So when talking about the cloud native culture, it is important to highlight beforehand what's cloud computing and showcase the business added value of the cloud. As you can see, the Oxford Dictionary defines cloud computing as the practice of using network or remote servers hosted in the internet, store, manage, and process data rather than local server. On the other hand, Microsoft sees cloud computing as delivery of computing services, including servers, storage or databases, network solutions over the internet. One question is why the cloud? And of course, one does not simply go to the cloud like that. So no matter the definition, cloud computing is always about enabling organizations to gain real added value in terms of offering elasticity, scalability, reliability, and increased productivity, and to offer flexible cost models. And those benefits offer different organizations from different backgrounds the possibility to drive innovation according to their specific needs and to their specific use cases. But despite all those buzzwords and promises by the cloud vendors, some serious questions can be asked by any organization before embarking on cloud native transformation. Things like, how can I efficiently use the different set of offers provided in the cloud? How to design my software in the cloud, and what modern architecture patterns are suitable for apps running in the cloud? How to choose the correct set of tools that help me to achieve my goals? And does taking my app to the cloud means resolving all my problems there? Those questions can be answered by adopting a set of patterns that forms what is called right now cloud native. Of course, cloud native and cloud computing are a bit different. They are simply not the same thing. That's something very important to note. So essentially, the community of software development notes it over the course of the past few years that taking your legacy way of doing to embark on a cloud migration or cloud journey won't deliver the real value of computing capabilities available there in the cloud. And that's exactly why there was a need to adopt a set of patterns that can achieve a native way of work and software development in a cloud environment. Those set of patterns empower taking the full capacity of the cloud, and adopting that kind of mindset isn't limited essentially into a specific type of services. It's about just architecting your app that is built to run in the cloud. And that kind of architecture empowers things like innovation, agility, and setting some sort of standards to modernize teams and strategies responsible for migrating apps into the cloud and things like that. So those set of patterns, unlike many other can think, are not only about choosing a set of tools like containers and Kubernetes and things like that, but we should clarify essentially that the way we adopt cloud native is much more than that. It's merely about adopting a set of principles and concepts that guide teams throughout the journey of developing cloud product. Those set of patterns can be categorized essentially into three sets. First of all, the organizational patterns, which are, in my opinion, the foundational patterns. We have also the infrastructure and operation patterns and the development and design patterns. Let's start by the organizational patterns. Like I said, in my humble opinion, they are the foundational patterns, and this is a very important thing to establish in any organization embarking on cloud native or cloud transformation journey. Things like agile development are the cornerstone of any software development practice, which relies on sharing a set of frameworks to face uncertainty and changes. Things also like efficient remote communication by establishing clear communication channels between the team members, and to establish efficient remote meetings and things like that. So those are essential elements of any organizational patterns. We have also the ability to establish a blameless culture. When problem somehow occurs, the focus should be only on the event instead of blaming the people who caused that, which allows, of course, those guys to learn from their mistakes without the fear of punishment or being left out or something like that. Also, things like gradual onboarding, establishing some sort of internal evangelism in the company and in the organization by creating an environment of trust between the teams and explaining and easing the cloud native concepts to all the teams, to all the members, and correcting any misconception there and easing the fear of change and things like that. Also, by ensuring ongoing education to all the teams and to all the engineers, to continuously run education programs about cloud native topics and organize activities like hackathons and internal schools like we do in our company, Maibornwolff, and things like that. Those are essential organizational patterns that we think are essential in any kind of cloud native journey there. We have also set patterns regarding infrastructure and operation, things like the cloud. This is essentially where all the modern applications should be running. Things like containers, this is how the modern apps should be shipped in the cloud. This is how they are shipped, and this is how an application is packaged. All modern applications should be shipped in the container with all their independent dependencies, which doesn't rely on the underlying runtime environment. So your application can run agnostically on any platform without the fear of any interferences between application dependencies and things like that. We have also the automation as the absolute majority of all the operational tasks need to be automated. Automation, of course, reduces the inter-team dependencies, and it allows faster experimentation and things like faster software development. We have also one essential element regarding the observability. This is a very important pattern that should be embraced by any organization in cloud native journey. Things like logs, metrics, alerts, and traces do truly enable having a continuous overview of the state of any system, of any modern system, that can be visible to anyone, that those specific information should be important for him. So those kind of patterns are crucial from infrastructure and operation perspective and standpoint. We have also some development and design patterns. One important thing is the microservices architecture, which relies essentially on reducing the cost of coordinating between teams by delivering large, removing that idea of delivering large monolithic application and building a new software, which is essentially a suite of modular services that are well deployed and operated independently from each other. Another pattern is the testing pattern. Every single application should be tested, and with that kind of thing ensure the quality and the enhancement of any release and any product and its consistency, and to be able essentially to continuously improve your application. One other important thing is the ability to reference and document everything. Everything should be referenced and documented in a way that can provide easy and access to the documents that construct the way your system is architectured, and to really reference every single know-how related to your project. Those are essentially the three families or the three set of patterns that should be considered when thinking about adopting the cloud native. But when you think about cloud native and you think about how to modernize your application, this is the question of how to architect your application. And that was essentially one of the previous questions raised in the beginning. So adopting the microservice-oriented application or architecture, like we said, should be the answer for that. We go from the dark ages where we used to deliver our application as a monolithic application to the modern ages right now, and to the modern world where we have a set of independent run services that construct our modern digital product. So when we look at this diagram right there, we find those layers that form the set of standards that define how modern applications should be built. In the first level, we see the cloud infrastructure. This is where our application should be run, and that applies to all the type of clouds, whether it's a public or private cloud or hybrid cloud. This is essentially where your application should be running. We also have the orchestration and scheduling layer. Platforms like Kubernetes, for instance, helps to dynamically manage our containers and to optimize the resource allocation of our platform. So this layer becomes more and more like a foundational layer there for any modern application, for any modern platform. We have also the layer of application runtime, which highlights the separation of the app dependencies from the underlying system and the underlying infrastructure. And finally, we have the focus, and we have all the time to focus on the application code and to really empower the developers to think about how to innovate and give much more focus on how the application should be developed rather than thinking about the infrastructure there. So those kind of layers and these kind of foundations should be empowered, of course, with concepts like observability. You highlighted that before, with automation, the ability to deploy and to integrate your work in a continuous manner, and with also things like we said, the organizational things like prioritizing team collaboration and communication and things like that. So those are, in our perspective, the how or the architecture of how the application should be built in a cloud environment and how the cloud native application should be. But of course, the architecture isn't enough. We should also really think and really know how to use specific tools that can empower such modernization journey. Cloud native, of course, is defined by better tooling that enables innovation in the cloud. And one of the major factors of adopting the cloud native is the success of some open source projects like Docker and Kubernetes. That's something obvious. And to help maintain such projects like Kubernetes and so on, one organization plays a pivotal role there. The CNCF, or much more clearly, the Cloud Native Computing Foundation, is essentially part of the Linux Foundation, which helps governing multiple and wide range of open source projects, like we said, like Kubernetes. Prometheus is also one of the major projects there. Containerd as a container runtime, and so on and so on. So just name a few there. And one website that can help finding those set of tools, those set of modern tools created to empower development, we can reference this landscape.cncf.io, which is a website that can, there we can find multiple projects maintained by the community of the CNCF and the organization of CNCF. There we can find projects grouped by level of maturity and the scope of the projects there. We can find projects around serverless, containers orchestration, containers runtimes, observability, and so on and so on. So we highly recommend, truly, for anyone interested in any cloud native tooling or any modern tool to embrace in the cloud native journey or to use it in his project exactly, we highly recommend visiting the website and navigate the maturity of specific projects and choose maybe one of those. Of course, it's not only about open source solutions, it's also about managed solution. The cloud vendor managed solutions plays a very important role in empowering the innovation in any cloud product. For us in Maibornwolff, and I think in any cloud native advocate team, we always think about those kind of solutions, not in a way of against each other, but we think about it as a complementary relationship. Sometimes the operational overhead of implementing some new features can be a factor to adopt managed solutions. Things also like the costs, things like the operational know-how and things like that should really be taken into consideration when choosing between this and that, and maybe ensuring some sort of complementarity between of them, because as maybe you know, some specific open source projects like Kubernetes are essential, but just trying to do that kind of constructing your platform with Kubernetes can take thousands and thousands of dollars to establish, and it takes a lot of time, it takes a lot of know-how, which isn't something obvious for any team. That's why opting for managed Kubernetes cluster, for instance, can save a lot of money, can save a lot of time, and can give real benefit there for any organization. That's why we definitely encourage any team and any organization that comes to us to opt for such managed services, like I said, for Azure AKS or EKS regarding Amazon and things like that, because they really give some benefit and some added value from an organizational standpoint. For instance, in my current project right now, we use a complementary set of tools between, I'm working with the monitoring and the observability a lot in my project, and we use there some sort of combination between Prometheus and Grafana open source projects with some Azure metrics and Azure logs provided by the Azure provider and the Azure vendor, which results really in a very good and productive insights for our state and our state of our systems. So like I said before, that depends mostly on the cost, the know-how, the operational overhead, and things like that. This is how we see it, and this is how we think should be advocated by anyone seeing that cloud native journey there. Speaking about managed services, I think one specific company took advantage of managed services in the early days to drive its innovation, to essentially set an example of successful cloud native transformation journey. Netflix obviously is the company. It was one of the early adopters of cloud native discipline, initiating gradual, let's call it digital transformation or cloud transformation that started circa 2009 and ended at the beginning of 2016. At that year, 2016, Netflix announced that all their services are now migrated to the cloud, and there is no more using of local data centers for them. They're using AWS resources for all their underlying infrastructure. And that was tremendous change from an organizational standpoint in that time. So for Netflix, the money wasn't the motive to start that transformation, but much more the cloud benefits, like we highlighted before, the scalability that cloud vendors can offer, the reliability there, the cutting edge solutions, among other things. And that really helped them to gain some edge there in the market and to really focus on modernizing their apps architecture by using the microservice architecture from the early days, and to really advocate their use in the whole community there. So obviously that wasn't an easy transition for them. It was a gradual transition, and there was a lot of learning along the way for them to achieve that level of maturity and to really be able to migrate every single thing in the cloud and to abstract the use of any infrastructure from their part. And the Netflix success story was a very essential motive, I think, for all the other organizations that came after that to follow the same path, to try to modernize their application in gradual manner and to achieve that kind of edge the cloud can give any organization there. So This was the cloud native, let's say, success story, but let's speak also about our success story in Maibornwolff. What it's like to advocate for such cloud native concepts and what it's like to be cloud native engineer in Maibornwolff. I think for any student there who's willing to maybe to be cloud native engineer, focus on those cloud native terms and cloud native patterns, I think the soft skills are essentials there. I think the ability to have some problem solving skills, the humility, the willingness to help other teams and other members in the organization, the curiosity and essentially good communication skills helps enormously to be successful cloud native engineer. Regarding the technical skills, I think there is no need to know a specific stack of technology. Most importantly, I think knowing the concepts and the patterns of the modern cloud platforms like I said before, automation, the continuous integration, continuous deployment, continuous delivery, things like Kubernetes and containers are essential because right now they are important in this transition to the cloud. But like I said, the cloud concepts are the most important thing. The tools can be changing, but the concepts are foundational there. And it is important to really know the concept much more than the tools itself. But for me, as a cloud native engineer, I think the most important thing is the ability to guide our team and our customers to more stable transition to the cloud by introducing concepts and patterns that fits according to our needs in the company, maybe Maibornwolff, or in the customer needs and things like that. So always thinking about adapting those kind of patterns and those kind of concepts to what the organization really need there and what they can really get benefits from it there. So this is how we see the opportunities, and this is how we evaluate challenges there with our customers and with our clients there. So this is essentially the cloud native culture part that's I present in the first part. In the second part, we're going to go into much more concrete cloud native topic, which is serverless. And this is where Jochen will give you guys much more insights about. So yeah, I think Jochen, the stage is yours now. You can focus much more on your part there about serverless.
Hi, yeah, thank you very much. I'm trying to share my screen as well. Okay. Can we get my screen up? Yeah, there it is. Hope you can all see the presentation. And as Chance already mentioned, we're going to talk about serverless. And one question that we always have to answer before any others is, what is serverless? And there's always, when talking about serverless, there's always this word serverless, which is kind of a misnomer because there are still servers. Of course there are, but it's more, or actually less, thinking about servers. So this less kind of makes more sense when you put it in front of the servers. But why is that? Because when we think about our gradual progress towards where we are today, from this on-premise where we had to take care of everything from hardware, like our data centers, our physical buildings, power, networking, all the way up to the application, we have been slowly chipping away our responsibilities. So while on-premise, we were responsible for everything, we actually outsourced most of that responsibility to our cloud vendors. So when we think about IaaS, so infrastructure as a service, we're getting rid of the hardware and the virtualization, but we're still in charge of everything above it. And then we have platform as a service, where we aren't even responsible for the operating system, the middleware, and the runtime anymore. And now serverless is kind of in between this platform as a service and software as a service. And I will go into why that is a little later in the presentation. But this has a very interesting side effect, which is that we're not only outsourcing our responsibility, but we're also outsourcing our uptime, if you will, because that just goes hand in hand, the uptime issue and our responsibility for it. Okay, so serverless, as I mentioned, there's no more server management, so you don't have to provision your servers, you don't have to order new physical hardware, you don't have to manage any Kubernetes cluster like that. It's just you and your application and your code, basically. So also no operational logic is required, so you're not provisioning any resources anymore. And usually, but not always, you have this pay-per-usage concept, which, as the name suggests, lets you only pay for the things that you're actually using. So usually you have a per time frame quota. So yeah, or per so and so many requests, you have to pay a certain amount of money. And serverless encompasses the functions as a service, or FaaS, which is the compute service. So your computations happen there. Functions tend to be event-driven and stateless. This could be a bit of a problem if you're developing something that needs to have a state, then functions are for you, probably. The other part is backend as a service. And backend as a service is offered by cloud providers, like a database would be a backend as a service, but many, many more things fall under that category. And this is part of software as a service. You only provide a configuration, and the entire software is then just provided to you as is, and you don't need to program anything yourself. You only need to configure it. Then there's also the thing that serverless is rather young. However, it's also mature enough to be adopted by a lot of companies and running real-world applications in production right as we speak. So it's just been around for 5 years, which isn't that long if we see that timeline here. It first appeared in 2012, but it's been gaining steam since 2016, mostly. So even though it's still kind of young, the progress is immense. And this graph is not up to scale, but it's just illustrating how it has exploded in recent years. Right, now that we kind of know what functions are, let's talk about how to use functions, and or how to use serverless, or should I? Would have been better, but anyway, there are mostly two categories that I've seen so far. That the majority of projects that I have seen personally fall into. And one of these categories is batch/data processing. And this has 3 or 4 major parts. Usually, as this is an event-driven system, or functions are an event-driven system, you need to have an event and a function that is triggered by that event. And usually that function interacts with some kind of data storage. So a database, data lake, file storage, an archive, something like that. I've just written data store here to illustrate that. And such an event could be, for instance, every day or every time frame, you go through your data and you delete certain entries that you're no longer allowed to have due to privacy or data governance issues, like the GDPR. And then you just delete that and you save the remaining data back to data storage. Another example could be that your function interacts with another backend service, something, for instance, like a machine learning service. So a typical example could be the user uploads a speech sample. That would be the event, the uploaded speech sample. That then gets to the function. The function takes it, puts it into the backend transcribe module software, and out comes some text, and that text can then be analyzed by another function, and that function outputs something. So, for instance, when you're talking to Alexa, this could, in theory, this could be what it looks like behind the scenes, that a function pushes your speech sample into some form of transcription, and the transcription gets analyzed, and then your lights turn on or your favorite music starts playing, whatever you told Alexa to do. Right. Other examples are email marketing. So if you have a user that aborts their shopping cart, you can send them an email. So your backend service would be your email service, and then you can save the email that you'd sent them so that you can later do some analysis of which email was the most effective on users aged 30 and above, or 60 and above, so something like that. Right. Anyway, moving on, the other big section or group of applications, I think, falls under the web application. Serverless web applications are usually divided into 2 parts, the front end and the back end, and they're both serverless. So the front end is just some static web page hosting, and most popular cloud providers allow you to host some kind of static web page. So that's usually just connected to some file storage where your files are, and then you have your single page application, like your Angular, React, or Vue application load from there through your static web page host, and that then interacts with your backend, usually through a gateway, so that your endpoints aren't floating around unprotected in the internet, and only authorized and registered users can interact with that, and you're not getting bombarded by some malicious requests. So usually also you have some authentication built into this, just to make sure that you can also have some monitoring. And the classic backend functionality is then handled by your function, which gets triggered through an HTTP request that passed through the gateway. And then the function can either fetch some data from a database or from some other backend service, like an image provider, or it could even send data there. So if you think about something like a social network here scenario, where you upload a picture and you need to then manipulate that picture by applying some watermark or cropping the image, doing some kind of facial recognition, stuff like that. That would be typically passed off into some backend as a service that's already there for you, provided by a cloud provider. The authorization and monitoring and the database and the gateway, they're all backend as a service applications. I just put them here specifically because they are specific backend as a service instances that you typically require, and I've left that generic backend as a service there for your imagination, whatever you want to do in your web application. You don't need to program that yourself. There's typically, or for a lot of scenarios, there's already a solution out there that you just need to use. So now that we looked at what serverless applications are, what categories and what architectures we can find out there, and what they can conform to, mostly, or a majority will probably. I'll look at some do's and don'ts that you want to either do or try to avoid. And these do's, let's start with a do. Use lightweight code dependencies because you're paying per usage. You want to keep your footprint as small as possible. And that correlates with avoiding large middle tiers. Again, for the same reason, you want to pay as little as needed, as little as possible. So don't use large middle tiers. Usually also an effect of having a large middle tier is that then somebody comes up with the idea of using multiple functions and functions triggering other functions. And this is also another no from at least for myself. I wouldn't recommend that. So functions should be glued. That's another do. And as I already kind of spoiled you with, functions being triggered by other functions is a don't. Now, what do I mean by functions should be connectors? As you've seen in the previous two examples, a function got triggered and then it did something like retrieve data or pass data somewhere, but it never did any heavy lifting. So in terms of the speech analysis example, the function doesn't do the speech analysis itself, even though it theoretically could do that because it's just compute. You don't want to do that for two reasons. First, it would be very costly. And second, you should, during development, be focusing on providing value for your customers and not solving so many or not solving as many as possible problems yourself. You should rather try to find pre-existing solutions that solve your problem, use those, and just use your own code as the intermediary between pre-existing solutions. Right, we'll get into that a little more soon. Another do is use services. That's what I've just detailed. If there is something out there you can use, much rather than writing your own code for it, just go ahead, use that service. And if you're unhappy with the service, then you go ahead and implement the functionality yourself. Right. Now, when you use a lot of services, especially when you use them from different vendors, one issue that you might run into is accumulating single points of failure. This is something you want to try to avoid. So usually you shouldn't. Usually you shouldn't span across multiple cloud service providers. So if you are within a Microsoft or an Amazon or a Google or an IBM or whatever context, you should try to find a solution within that ecosystem first before looking outside of that bubble for some other solutions and some services. Right. Last but not least, writing custom code that heavily correlates with the function should be connectors, because the more custom code you're writing, the less likely it is that your functions are just connectors, or the less maintainable your software will become overall. Probably. I mean, you can have huge software projects with millions of lines of code, and they're still maintainable, no doubt about it. But yeah, it's just generally something you should avoid when dealing with serverless and functions. And last but not least, monolithic deployments is the last do. Now, this is something that I feel like most developers are struggling with when I tell them that monolithic deployments are actually a good thing, because I guess it seems sacrilegious to them that monolithic deployments are actually a good thing. But I will now detail a little bit why that is. So if you think about a monolithic deployment, then it's just one application and everything goes in and out of that one application, right? So this is kind of illustrated here, where you up top have some clients and some web page or a web interface interacting with your software, and that then has connections to some backend services like a database, for instance. Now, if you use that and you deploy, everything should work. However, it doesn't scale very well, at least not individually. And sooner or later, you will have to split that up. And this is actually a good thing, because if you start with a monolithic app and split that up later, you kind of know for sure where to draw your, or where to cut up your monolith, and that's actually a good thing, because you can be sure that you made the right decision. After you cut your application into smaller pieces, it kind of could look like that, right? Just as an example. Now, you can't deploy this in monolithically anymore, because these are all individual functions now. And when you deploy new functionality or a new version of your application, what will happen is you will start out with them all having the same version, in this case, version 1. Now, when a request comes in from the user, there's no problem at all. It will just pass through the individual functions, it will get returned, everything's green, everything's perfect, everything's fine and working. However, once you start deploying your version 2, one function will have that update before others do. So for instance, this could just, in theory, could look like this. And now what happens if you have a client sending in a request, that request will be a version 2 request up until it hits a function that is still working with version 1. And if that request is incompatible, it will fail. So this is illustrated here by the dot turning orange or red. If the request itself doesn't fail, then it will fail later when the version 2 function receives an answer from a version 1 function, and the data objects in the response aren't compatible anymore, and will fail here. If you look at this right now, it's fairly obvious to see why you would experience a downtime here, at least as long as it takes for all these functions to receive the update to version 2. And this is really bad because you ideally want to be able to deploy multiple times a day, and you just can't with that setup. Okay. However, now that we talked about some do's and don'ts, let's go over some benefits and challenges. Benefits are, or I've split them into 3 categories: deployment, development, technical, and business. And development, we kind of talked about a few of these already. For instance, the less code one, but the less dependencies is also pretty significant, because you're no longer depending on other teams, other people to finish their work, because you're already using services that are already existing, right? So when you want to have a database, you don't need to wait for a database architect or a database developer to finish setting up your SQL tables and writing all kinds of optimizations, making sure that the indexing is working properly. You just go to your cloud vendors, say, hey, I need a database like Azure Cosmos DB or Dynamo from AWS. You just go there, take it, turn the key, and it's working. So you're no longer depending on other teams of your company to get their work done. The less code part, I wanna say here, also from a business perspective, this is really valuable, because code can be thought of as a liability. You're investing money, effort, and time into developing custom code, so that custom code better return a profit and be worth your investment. Because if it's not, then you kind of made a mistake here, investing your money into it. And if you just pay per usage, that's just like outsourcing the problem to the liability problem to the provider of the service you're using. Easy to test. I put an asterisk here behind it because, yes, in theory, it is very easy to test, because you can just create a complete environment that is identical to your production environment. But testing, I think testing is never easy. So in theory, if your CI/CD is rock solid, you shouldn't have a problem with creating a separate instance that is identical to your prod environment. Test everything there, run all your end-to-end tests, and if they all come out green, you're good to go. There's no problem. You can be sure that you found all the bugs. Now move on to technical. There's no server management anymore. That should free up some of your developers' capacity to work on actual business and customer problems, so providing actual value to your customers. Also, this benefit is that there's less security concerns that you need to worry about, because this is all being handled by your cloud provider. But of course, then there's also the uptime issue, which is quite horrible for a lot of people apparently, because if your service is down, if your software, your application is down, there's not a whole lot of things that you can do. There's the most thing that you can do is call your service provider, your cloud provider, talk to them, but beyond that, nothing that you personally can do here, which I can see why people are scared of that thought. Anyway, easy to scale. I think that's pretty simple. I don't need to waste much time here. Scaling is pretty much handled by your cloud provider as well. And you just need to configure how much you want to scale and when. Cheap during production, since you're paying per usage. Whenever your production environment is not being used, you're not paying. So that's pretty neat if you're just starting out, and also helps you that it scales automatically for you. Your focus is on solving business problems and not solving scaling problems, solving security problems. That's all being handled for you, so you can completely focus on the user experience and making that as perfect as possible. Cheap, fast, and easy development. Kinda, yeah. This is a little bit exaggerated, but yeah, since you don't have to code every functionality yourself, you're faster, you're cheaper, and it's also easier because you already have everything, hopefully everything well documented and ready to be used out there for you. Okay, challenges. There are development challenges because if you want to do state management, you shouldn't use serverless, you should use functions. State management and functions is almost impossible. Code reusability is a bit of a problem because your functions are going to be highly specialized to serve one purpose only, which is to take data from place A and put it into place B. You know, the whole functions are connectors thought here again, so they're hard to reuse. Local development environments are not really existing right now. There are a few tools here and there that are trying to simulate a cloud environment or trying to help make it easier for you to develop locally. However, this isn't like the real thing, so there are always going to be problems, and yeah, basically you need to check your code and see what it does once it's in the cloud. Developer mindset is a big problem because there tends to be this notion of developers identifying themselves by what they do in terms of, I can make this application scale up to 1,000 or 1,000,000 instances and never have any faults or never have any desynchronizations, whatever. This is super cool if you can do that. However, if this is what you're only interested in, then serverless development probably isn't for you. Serverless development specifically demands from you that your highest priority and the thing that you should take pride in is providing value to the customer and not solving some obscure problems. Consistent deployments, as I already mentioned, as soon as you step away from the monolithic deployment, you could run into some problems here and there. There are solutions, however, this is going to be a problem that you need to take care of. Technical issues, cold starts are an issue. So the first request to your application, if it hasn't been active for a while, tends to take long, like very, very long, and may even fail because your app needs to start up and needs to warm up before it can actually handle any requests. But there are also solutions to that. Execution limitations. This is in terms of time. So your functions are only allowed to run a certain amount of time, couple minutes, couple seconds. Oh, I didn't want to do that. Okay. And the not your uptime problem. We already talked about that as well. Business vendor lock-in is a very, very tricky thing. I personally think that this is not as big as a problem as people think it is. Yeah, if your provider suddenly increases the prices by 10-fold, 100-fold, you're going to be in a pretty bad situation. But first of all, I think it's unlikely that they will do this. And second of all, if at any point you feel unhappy with a service you're using, you already have a perfect definition of an API that you need, that your application needs, and all you need to do now is take the service, implement it yourself, and make it API compatible. And that, I think, is a lot easier to do as a second step rather than as a first step. So if you have to first implement your service, before you can see any value, before you can evaluate your business model, if it's really working in the real world, if people are interested, and if customers are willing to pay for your product, this is a huge liability. And vendor lock-in is, compared to that, is almost insignificant. All right, cost explosion is a bit tricky, yeah, because it's pretty hard for you to estimate what your cost will be, because if your usage goes through the roof, then your cost will explode as well. And there are ways that cloud vendors will support you here. They are aware of this problem, and depending on your cloud provider, there are solutions of monitoring your cost and also capping your cost at a certain limit. Comparing cloud vendor offers is also a pretty challenging topic here, because they don't make it easy for you. Usually they have different offers that are just slightly off, and some will even offer you things that you cannot find a one-to-one equivalent in another cloud vendor's ecosystem. So comparing them gets really hard. And security and privacy is just an issue because you are giving your application and your data to another party, and you just need to trust them that they are treating your data, your application, your code the way that you want them to treat it, and that they're not, I don't know, undermining any trust that you have in them. So yeah, I mean, this is a pretty big problem whenever we're talking about cloud and running software in the cloud, and that people need to trust the cloud provider, that they don't spy on you and your data and your customers' data, essentially. Right. Anyway, tools are pretty wild. This is the CNCF landscape for serverless, and as you can see, there are numerous tools and products out there that you can just dive into, and there's not really anything that I could recommend from the top of my head, other than the big three: Google, Amazon, and Microsoft. They all have very excellent services, but you just, if you're interested, just pick any, look into it, evaluate its value for you personally, and see what you can do with it, basically. Right. With that, I'd be open for questions if we have any. And thank you very much for your attention.